So my name is Carmen, and I'm a software engineer at a company called Valiant Finance. And today I'm here to talk to you about three things. First of all, what is an XSS, otherwise known as a cross-site scripting attack? Secondly, what does React do to protect you against such attacks? And finally, what happens when you circumvent such protections? So let's say you're a web developer with a website, and you allow users to submit comments that you then display without sanitizing the input. An attacker can come along and inject a malicious script into your website. When an innocent victim comes along and they visit your website, their browser is actually going to run that malicious script because it thinks that it's coming from a legitimate source, which is your website. Some of you might be a bit too young to recognize this, but it's a MySpace friend request list of a man named Sammy. In 2005, the Sammy worm infected over 1 million users within under 20 hours of its release, making it the fastest spreading computer virus of all time. All thanks to an XSS attack. And before you think that this is just a one-off, Precise Security estimates that almost 40% of all cyber attacks in 2019 were performed using cross-site scripting, outranking the next most frequent by a whopping 25%. The good news is that frameworks like React do offer out-of-the-box protection. So for example, they automatically escape string variables in views, and if you're using JSX, you can pass a function as the event handler rather than a string that can contain malicious code. However, there are still a number of ways in which your React web app might be vulnerable. And today, we're going to look at just one of them. Dangerously set inner HTML is a prop that will update the DOM by calling the native .innerHTML method on your DOM nodes, essentially replacing children of a React DOM element with a raw string that is passed from a user. And it's raw string that could include any sort of arbitrary HTML, including script tags. So before we get stuck into the demo, I want you to have a close look at this Twitter login page. You might notice that there are actually 3 T's in Twitter, and the reason why is that this is not a real Twitter login page, it's just a dummy clone that we have created. Okay, so let's say that we have an online forum for React Conf, where people like you, participants, can log in, you can submit your name, Twitter handle, and a comment. And we've decided to use dangerously set inner HTML because we want to allow all of you to do things like personalize your comments with bold and italics. An attacker can now inject an iframe with the fake Twitter clone that I showed you into this website. Let's take a look at how they do that. Oops, sorry. Uh-oh. Oh, no. Oh, dear. Sorry, I swear this was actually working before. Oh, it is working. Oh, sorry. Okay. I'm so sorry. Okay, so I'm going to rush through this now. We've injected the script, and it's actually calling the website that we've created. It's not actually showing up on my screen. Great. So now we're going to be an innocent victim, and we go over, we have a look, we see why hello there. If you scroll down, there's that Twitter login page. And down the bottom is the actual real comment box. So if I was a person visiting this website, I would think, well, maybe I actually have to log into Twitter in order to be able to comment. So I would actually add my username and my password. And of course, this is a fake cloned Twitter page. So now the attacker actually has my Twitter credentials. Let's take a look at another example. So we have here a database with a collection called stolen cookies. I'm the attacker. There is nothing actually in that at the moment. I go back to the website, and I'm going to actually call an image called blah, but of course that's going to error. On the error, I'm going to use the fetch API that's in your browser. I'm going to take your cookie, and I'm going to post it to my cookies endpoint. So I've done that on the attacker's browser. I'm going to jump over, be an innocent victim in a separate browser. Refresh the page, and you will see that there's that image that has errored. I've actually logged in, so I've got my cookie here, which is your cookie, and secret cookie business is the value. If I'm the attacker, I go back to my database and I now go check and refresh. All of a sudden in my stolen cookies, I have one item and it is that cookie. Right, so if any of you were to go to the website that I've created and you had a cookie stored on that website, it will now end up in my attacker database. Obviously, this is incredibly dangerous because as an attacker, they can now impersonate your users. So what can you as a React developer do about this? Reconsider using dangerously set inner HTML. Quite a few people have been removing it from their repos, and that's a good start. If you do need to use it, then sanitize your inputs, preferably on both the front end and the back end. Finally, you might want to consider using a linter that detects improper usage and that actually warns you when you've failed to sanitize the input. My name is Carmen, and it has been such a pleasure being up here on stage. I will be tweeting a blog post which will contain much more detail on all sorts of XSS attacks that can occur against React apps, including the dangerously set inner HTML example that I gave today, but with a bit more detail. So if you're interested, please follow me on @CarmenHChung. And I would also like to take this moment to say a special thanks to my colleague, Luke Thompson, without which this demo would never have happened, despite my little video glitch. Thank you very much.